Welcome. This is the lesson on horizontal projectiles and specifically how to solve these problems. So with horizontal projectiles, they're actually just kind of special types of projectile problems. The basic idea is pretty much just that you have some cliff or some slope or something, and your projectile has an initial velocity that is completely horizontal. And then of course, eventually gravity takes over and the projectile goes down. What's nice about this is that it actually essentially just takes apart if you think about a projectile that launches up and comes back down, really just starting from this top point here and calculating everything from there to the ground, essentially. So that's what we're going to be focusing on, and we're going to solve for essentially 3 different types of problems. So this first one that we have here is the ball is launched horizontally with a speed of 10 meters per second from the top of a 25-meter high cliff. How long did it take for the projectile to hit the ground, and what was the range of the ball? So this one we're actually the end goal is solving for range, which is going to end up being your horizontal displacement. So if you ever hear horizontal displacement or range, I'll sketch out a picture, and it just means simply, right, the ball gets launched, it does something like that. Your change in x down here, that is your range. And we're given some things. So we have a change in y that we're given. That is 25 meters. We're given a velocity. So our vx, or horizontal velocity, is 10 meters per second. And that's pretty much about it. So to solve this problem, we have 2 ways to go about it, right? We have the horizontal direction and the vertical direction. So if we're looking for how long did it take for the projectile to hit the ground for part A, right, so we'll do part A right here. What we're really looking for is how quickly does gravity bring that ball to the ground. So really, what we're really solving for is just a ball dropping 25 meters. Right, so we're just taking the vertical components of this problem and solving them independently of the horizontal ones. So if we were to do this problem, our initial velocity in the y direction, well, it's 0. Gravity, of course, is going to be 10 meters per second squared. And we're just solving for time. And we have then 3 variables that we know and 1 that we do not know. And so we just have to plug in an equation that we know. One equation is your distance, or sorry, your vertical displacement is equal to the initial velocity in the y direction, which that should be small, multiplied by t plus 1/2 times your acceleration multiplied by your time squared. However, your initial velocity is 0, so this just cancels out. And you're actually left with just this. And our acceleration is really just gravity, so I'll throw that g instead of the a. And we have our t squared. Now we need to solve for t. Well, t is going to be equal to, if we do some algebra, we have to multiply both sides by 2. That cancels that out, and then divide both sides by g. And then these cancel out. And then finally, we've got to square root everything, right? So what we really end up with is the square root of 2 change in y, gravity over, sorry, the square root of 2 change in y divided by gravity. And if we just plug that all in, we get square root of 2 times 25, which is 50, divided by 10, which is 5. So we're getting the square root of 5. And if I calculate that, we are getting 2.23 seconds. And that would be your answer for part A. Now, what that also means is that this projectile can only travel horizontally for that long, the 2.23 seconds. So I'm going to delete all of this right here. And so now we're going to solve for part B. How far did it go? So the nice part about this is that we know that it traveled for 2.23 seconds. So our horizontal velocity, which is 10 meters per second, that means that the ball can only travel horizontally for 2.23 seconds. So really, we just have a ball moves horizontally at 10 meters per second for 2.23 seconds. And then we ask, how far did it go? Well, the simple equation that we know is velocity equals your horizontal displacement over time. And we just have to solve for that horizontal displacement. So we get VT, velocity times time. We just plug that in. That's a really easy math problem, but I'll still write it out. We get a range or horizontal displacement of 22.3 meters. So that ball launched out 22.3 meters. So if I ever ask you for how far, that is what I mean. Now we go to another problem, and we have Jimmy runs and jumps off a horizontal cliff. That's bad. That should say runs and jumps horizontally off a cliff. So runs and jumps horizontally off a cliff. The cliff is 10 meters tall, and he lands 3 meters away from the foot of the cliff. How long was Jimmy in the air for? Again, we're just answering for time. And how fast was Jimmy moving before he jumped off the cliff? We're looking for Vx. So if we were to draw that problem out, we have 10 meters tall, and we have 3 meters away. 3 meters would be much smaller. And our question then is, see if we can draw that a little bit better. What is his velocity? That's eventually what it's going to be. So solving for time again, we're really just looking for an object that goes down where we know our change in y. Don't know time. We know gravity. And then we also know our initial velocity in the y direction, which is 0. So we're just going to be using the exact same equation we did from the previous problem. This time I'm not going to write in that first portion because we already know that VIT, the initial velocity times time, is just going to be 0. So it's just 1/2 AT squared. But this time we are looking for time. Oh, sorry, we were doing that for both parts. So the time reduces down to a very easy 2, change in y over gravity, and we're taking the square root of that. And if you forgot how I got that, just go back in time to where I solved for it right here. And then so let's just solve it. So t is equal to, we have 2 multiplied by 10 over 10. These 10s just cancel out. So we're really just doing the square root of 2. And that will get us a time of 1.41 seconds. So this is the part A answer. And then how fast was he moving? Well, again, we know that velocity equals the horizontal displacement over time. And we know the horizontal displacement was 3 meters. So we have 3 meters over 1.41 seconds. And if we solve for that, we get 2.13 meters per second. So Jimmy was running roughly 5 miles an hour, which is like maybe a good jog when he jumped off that cliff and landed in that water. So there we go. That's the second one we solved for this time. How fast? Next we have a kitten, and it jumps off horizontally from a building structure with a velocity 10 meters per second, and it lands 2 meters away. Again, we're being asked for time. If you didn't notice, I asked for time in 3 different ways so that you can kind of see like how I'll be asking these in the future. And then how tall is our building? That is a change in y. So, we start off by drawing it. I'm going to try to draw the best kitten I can draw. It has a tail, right? This is its tail. And then it jumps off, right? And we're looking for a change in y. we know 2 meters away, right? 2 meters not too big. We know that the velocity was 10 meters per second. So first we were asked how long was the kitty's hang time. So again, we break this problem into 2 separate problems. Change in y we do not know. But we know the initial velocity in the y direction was 0. We know gravity is 10 meters per second squared. And then we also know, we don't know the time. Well, this is a little bit harder because we've been so used to solving for time that we can't do it this time. Well, what we can do instead is find out the time from a different kind of angle. So let's look at, because in this part, we weren't really given anything to do in the horizontal direction, but we're given a lot in the horizontal direction. If you look at it, we have this and we have that. So we have the horizontal velocity and the horizontal distance, which is the range. So we can solve for t, and then once we do, that can go right back in there. So if we solve for t, we get change in x over our horizontal velocity equals our t. And then that is a 2 meters over 10 meters per second. That's going to give us 0.2 seconds. So cat is not in the air for very, very, very long. So now we're just going to plug that in. So you have now 0.2 seconds, right? And all of a sudden we have answered part A. Now we're answering how tall is the building. Well, that's easy to find out because we have an equation for that. Change in y. And again, we don't need the next portion. We have 1/2 at squared. And it's already in the form that we need it in. So you have that times 10 times your time squared. So if I do this really quick, we have 0.5 times 10 times 0.2 squared. And that gets us a very easy 0.2. So we have a structure, a building structure, which is 0.2 meters tall, which is not tall at all. Just so you know, I made it say building structure because I wasn't sure what height I was going to end up with. So we get 0.2. That's not terribly high. It's actually really, really low, but that's fine. So that is what I have gotten. So that is it for the horizontal projectiles. In the next video, we'll be looking at angle projectiles, which will, they might be a little bit harder, but they probably will take a lot less work than these do. So that's all. Hope you guys had learned a lot from this. If you have any questions, please let me know.